All right, so here we are on number 41. This is from 11.4, by the way. And this is a very similar or the same question from that homework. And I drew it out because since this is black and white, it's hard to kind of see what's blue versus green. So I just sketched it. This is extra. This is an extra little square, so it's all green, by the way. All of this. Okay. So what I'm going to do for the practice test is I'm going to give you the abridged, oops, can't spell it, abridged solution to the dartboard question. I did kind of go through the abridged part in the 11.4 notes homework or 11.4 homework videos, but I'm only going to do it here because I don't want to take up too much time since it is the practice test. Here's how we do this. The probability of this, in this case, of getting green. Okay, so I'm going to fill in some stuff here, but I'm going to do some work somewhere else. Okay. We first need to know what number goes on the bottom. So the number that goes on the bottom is the area that incorporates the entire dartboard. So all of this is the area. Well, I suppose I need to remind you the area of a square is S squared. So if you have a square and every side is S, then it's length times width, or S times S. So in this case, it will be 14 times 14. So 14 squared will go on the bottom. And I'll work this out, but just so you know in your problem, you can look at those numbers and know where to put them. What I need to do is I do the same thing with my blue and green squares. When I go up here, the areas of green will be positive, and the areas of blue will be negative, or it gets a minus sign. What does that mean? We'll watch. Okay, this 10 is this length here. So the area of this green square, which includes all of that, is going to be 10 times 10, or 10 squared is 100. Now I have to go in and I have to subtract off this blue square, which is 6 times 6. Then I have to go back and add in this green square. So that's what I mean. We're going to add the blue squares. We're going to add the green squares and subtract the blue squares. The only, I guess, time that doesn't happen is when we find the area of the entire dartboard. All right, so let's work this out. That's 100 minus 36 plus 16 over 196. If you type it in, let's see what I get. 100 minus 36 plus 16 is 80 over 196. Divided by 196, I can fix that. 80 divided by 196, second PRB, I get 20 over 49. Okay, so that's about the quickest I could think of how we could work that. All right, so let's move on. 42. All right, 42. A group consists of 4 men and 5 women. All right, so this, I think, We are moving into 11.5 now. (42). All right, a group consists of 4 men and 5 women. 4 women are selected, 4 people are selected to attend a conference. This kind of reminds me of 11.123 mix, and then they're wanting probability, so I'm thinking we got to use that trick in a previous example of the practice test. We're going to come up with the combination. We may have to multiply some combinations to then figure out the total. So here we go. Part A, the number of ways to select 4 people from the group of 9. Well, I can do that. The number of ways to select 4 people from a group of 9, well, does order matter? Order doesn't matter, so 9 choose 4. Type that in the calculator. 9 choose 4. I get 126. Okay, that's what's going to go in part A, 126, part B. In this example, I like this one because they're building it up. They're not going straight to say, what's the final answer? They're saying, let's break this complicated question into several parts. Okay, now the question is, the number of ways to select 4 women from a group of 5 women. Number of ways to select 4 women from a group of 5 women. Now, order doesn't matter. So 5 total women, we want 4 of them. Oops. I was going to do it with the formula, but I might as well just use the button on the calculator. Okay, if I got 5 women, I'm choosing 4. There's 5 ways to do that. Since we're only choosing 5 women, then the probability to choose, I said 5, but since we're choosing 4 women out of all of these folks, 4 women, is going to be this number over this number. That's it. So that's why I like it, because we had to do the denominator, the numerator, and that's it. So let's see if that reduces. 5 divided by 126. Use my little PRB there, and it's the same thing. So that's my answer. All right, so we're getting, since we're in 11.5, these are going to probably get slower. Yeah, there's 44. That's talking about a jackpot. I think the next one after that will be that minimum jackpot. Right. Let's do 43. I might decide I want to stop after this one. I don't know. We've only done 2 so far, so maybe I'll get through this page. All right, here we go. 6 comics are going to perform A, B, C, D. On a single evening, the order of the performances is determined by some random selection. All right, so what I'm trying to do is I want to find the probability that comic C will go last. Probability C will go last. Okay, I feel like we need to do something else first. Okay, so I'm going to do that over here. In the previous example, I found the denominator first. I need to do that here. Okay, so in how many ways can we order these 6 comics? So 1, 2, 3, 4, 5, 6. You probably already beat me to it and you know what it is. 6 could go first, 5. So this is just 6 factorial, which is 720. That's going to be my denominator. But let's see what happens. All right, that's my denominator. All right. Let's try to figure out A going or C going last. 1, 2, 3, 4, 5, 6. First, second, third, first, second, third, fourth, fifth, sixth. C, I said it before, but I have to say it again. C is last. There's only one way for C to go last, so I put a 1 there. All right. Maybe that's Jerry Seinfeld or somebody famous. So they get to like the last spot. All right, now we got 5 spots, 5 people to choose from here, 4 to choose there, 3 here, 2, and then 1 there. So if I multiply these together, you recognize that as 5 factorial, which is 120. Okay. So the probability of C last is this number over that number, 120 over 720. 7 minus 1 is 6, so 1 6. Don't listen to that, was a joke. What I should do is 120 divided by 720. And I get this decimal, second PRB, and I get 1 6. So that's really how I get 1 6. That was made up math. Part E. Comic D will perform 5th, and comic A will perform the last. So let's do that. Maybe I'll come. All right. Let's read what they want again. Comic D will perform 5th. 1, 2, 3, 4, 5, 6. First, second, third, fourth, 5th, 6th. I have to keep saying it because I forget it by the time I get to it. Okay. Part B. Comic D will perform 5th. Okay, so D has to be here. And comic A will perform last. Comic A will perform last. So now I look back at this. Once I've set those two together, I now see how many I have left. I had 6, and then I placed another one that makes 5. Now we have 4 times 3 times 2 times 1. So that's equal to 4 factorial, which is 24. So the probability of D 5th and A last is going to be 24 over my total, which was 720. So if I type that in, surely it will reduce. So 24 divided by 720. Fix it with my second PRB. I'm going to end up using that a lot. 130. All right. So, and now part C. So I need to probably turn my paper here. What are we doing in part C? Okay. Let's talk through this one. The comedians will perform in the following order. 1, 2, 3, 4, 5, 6. I'm just going to place it right there. They're going to perform in the following order: C, D, A, B, E, F. So anytime I'm labeling a one of these, that's going to be set. So there's only one way C can go first. One way B can go second, et cetera, et cetera, et cetera. 1 times 1 times 1 is just 1. So that's my numerator. My denominator from earlier was that. So 1 over 720. So the probability of C, D, A, B, E, F is 1 over 720. I wouldn't be surprised if part C on that question for you is also 1 over 720. All right, so part D. I feel like this video is going long, so I'm probably going to stop it after this one, even though we got only 3 problems. All right, so 43, part D. See if we can get it to focus. All right. Comic E or comic F will go forth. So 1, 2, 3, 4, 5, 6. I'm doing these blanks a lot. That just helps me. Part D. All right, so I've already counted these. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Comic E or comic F will go here. So what I'm going to do is call this E or F. Okay, it's not wanting to focus. Maybe when I start writing better. Since only E or F can go here, I put a 2. All right, sorry about that. So E, this says or, E or F. I have 2 options. Now, once I've chosen one of those, how many choices do I have for the first one? Okay. I was going to say 4 because I have 2 of these, but I've only put 1 there. I just have 2 options. So we have 5 for the first position, 4 for the second, 3 for the third, 2 for that, and then for the fifth, and then 1 for the sixth. So this is a little tricky, I suppose. But since E or F, I have 2 options. So it's going to be, this is 5 factorial times 2, but if you just want to type it directly, then you can do that as well. So I got 240 if you type that all in. And remember, our denominator from from earlier was 720. So the probability that E or F is fourth is 240 over 720. And if I do that, I get a decimal, I can clean it up, and it's just 1/3. Okay, so that's another kind of tricky one. So I'll try to do it a little slower. Yeah, so let's do another video for number 44, which is next. And I think, oh, maybe not. There's maybe not that minimum question. Okay, maybe I misremembered. Good. All right, so we're going to stop it there, and then we'll do this one.